Good afternoon, everyone. Today we're going to do an example where we are given the fact that g of f of x is equal to some quadratic defined by 2x squared plus 16x minus 3. Now this is going to be in the composite function section of Precal 12. So our goal is to find some appropriate functions for f of x and g of x that would make this work out nicely, okay? Now, I have to preface this by saying there exists an infinite number of possibilities for f of x and g of x, right? We're just tasked with finding one such pair of functions, okay? We can talk through a few of the possibilities, but you'll see that there does exist infinitely many, okay? So, first of all, we can write this. Some of you might have the hunch of writing this quadratic in vertex form or in transformational form, right? You might be so used to doing that, this is kind of like jumping into the paycheck. So if we go ahead and do that, g of f of x could be written as 2. Let's factor the 2 from the first two terms, and we'll have x squared plus 8x minus 3, and then we can write this in transformational form by completing the square, right? So that's 2 bracket x plus 4 half the b value, and then all squared. Now, we just created x squared plus 8x plus 16 times 2. 16 times 2 is 32, so we need to balance it out, right, by subtracting 32. And so we can finish by writing g of f of x like so. Okay. Now the reason why this might have been a hunch for you is because now we can kind of imagine plugging in something inside the bracket. So at this stage, if that's g of f of x, right, then we could write g of x as 2, let's say x squared minus 35. And then all we would need to have for the function inside of f of x would be to change the x to x plus 4, all squared. And so we could have f of x be equal simply to x plus 4, right? Because then g of f of x would be 2. Every time we have an x in g of x, we replace it with, right? Instead of x, we have f of x. So every time we see an x, we replace it with the entire function f of x. So the x becomes x plus 4. And the 35 doesn't contain an x, so we can't do anything to it. And so we get our function back right away. Right, that is just one of infinitely many possibilities. Another much more straightforward one, which some of you might have jumped to right away, is we could literally make, g of x be equal to x, right? And have f of x be 2x squared plus 16x plus 16x minus 3, right? Because if we have it this way, then g of f of x means in g we replace the x with f of x, so we're going to replace x with f of x, right? And so of course g of f of x would again just mean plugging this into the only x in g of x, and so of course we get back the exact same thing, right? Another possibility that one of my colleagues presented to me was to have g of x be x minus 3 and having f of x being 2x squared plus 16x, right? Another example of g of x becoming g of f of x means we replace the x in g of x with the entire f of x. So we replace the x with all of 2x squared plus 16x, and so this becomes that, and so we get back 2x squared plus 16x minus 3 right away. Fairly straightforward. So these are just 3 possibilities. I'm sure some of you guys can come up with other ones, but just the idea of whenever we have a composite function, g of f of x, all we're simply doing is, well, however g of x is defined, everywhere we see an x, we replace it with f of x, right? So we had an x here, and we had f of x being x plus 4, so we replace the x with the entire f of x. right? Here, g of x was x, f of x was this entire thing. So g of f of x means that every time we have an x in the original g of x, we replace it with the entire f of x. And so we just put all of this right into the x, right? If we had x squared plus x, we'd have this all squared plus that by itself, right? Instead of composite functions, we replace the entire thing, replace x with the entire function that is inside of the brackets, okay? So, hope this helps. Thanks for watching. If you guys have any questions, comments, suggestions, please leave a comment. Take care.